Now let us discuss principle of duality. It is possible for us to find out the relationship between controllability and observability of a specific matrix or a specific system. For example, let us consider x of k plus 1t is equal to g x of kt plus h u of kt, and y of kt is equal to c x of kt. Now when we are having these systems, a dau of kt can be ignored in this case, and let me say this is system S1. Now it's dual system. We can consider this another system, which is x of k plus 1t, x cap of k plus 1t is equal to g conjugate transpose of x cap of kt plus, this is h u of kt here and c x of kt here. We will just interchange these matrices, c conjugate u cap of kt and y cap of kt is equal to h conjugate transpose x cap of kt. Now this is the dual system, and let me say this is called as S2. Now S2 is the dual of S1 and S1 is the dual of S2. Here let me just give the nomenclature of x of kt. Let us say x of kt is state vector at kth sampling instant, state vector at kth sampling instant, and it is an nth order state vector. Similarly, u of kt, it is an input vector of at kth sampling instant, right. All these are at kth sampling instance, and it is an m dimensional m by 1 vector, right. And y of kt is output vector at kth sampling instant and let me say this is r dimensional r by 1 vector, right, input vector. So this is for these systems, this system S1. Now, and we also know that G is an n by n vector, is a system matrix. H is, since U is m by 1, H should be n by m vector, and C is, since this is y of kt is r by 1, this is r by n, right, r by n vector, right. So we have these systems of this form G, H and C. Now when we consider to write all these vectors here for all these names for this vector, this system, we have x cap of kt is again state vector of n by n. X cap of kt is state vector at kth sampling instant, and it is of order of n by 1. Similarly, u of kt or u cap of kt, this should be of, again you are going to change this vector here because this is an input vector at kth sampling instant, and for example let us say C star. Let us first write C star. C star is nothing but, now you have this as, for example, n by 1, and this as m by 1 because it is r by 1. We are interchanging these values, so this is nothing but m by n. Now H star is an m by n vector. H star is m by n vector, it is interchanged, and C star is R by N because it is conjugate transpose of C matrix. C star is conjugate transpose of C matrix, H star is conjugate transpose of H matrix, so it is interchange M by M by N, and it is N by R. In fact, it is N by R. So if when this is N by R, automatically this becomes R by 1 because this is N by 1. So U of kt is an R by 1 vector. So it has interchanged, and y of kt, y star of kt is an output vector at kth sampling instant, and the order of this matrix is M by 1. Right. So, and G star, C star, G star is again conjugate transpose of G, which is an N by N vector. Right. Similarly, H star is conjugate transpose of H, and C star is conjugate transpose of C. Now, when we all have all these things, now it is possible for us to find out the relationship between controllability and principle of duality. It is relationship between controllability and observability. Now it is very important for us to find out the dual system of the given matrix. Now if we are given this matrix, then you can find out the dual system. When these two dual systems are existing and the order of these matrices are of this sort, then you can easily say that the controllability, if this system is controllable according to principle of duality, the principle of duality states that if system S1 is controllable, then system S2 is observable, or if system S1 is observable, then system S2 is controllable. Or in this reverse process also happens. If system S2 is controllable, S1 is observable, and if S2 is observable, S1 is controllable. So for that we can just have a small table of sort: system S1, S2, and if this is controllable, if system S1 is controllable, system S2 is observable, and system S1 is observable, system S2 is controllable. Right. So this is the principle of duality. This states that controllability matters. Now, if you can say, if we have what is controllability matrix for this, you have H, GH, so on up to what is controllability matrices. Here we are having controllability matrix QC. For S1 is H, GH, G power n minus 1h, and rank of QC must be equal to n. If that is happening, if this is controllable, then automatically this is observable. Right. Observability of this states that Q naught, or I'll call this as star because S2. For Q naught, you can say this, or you can say CG power n minus 1. Right. The rank of this must be equal to n, or this can also be considered in this form. Right. You can say you are having in this fact, in this I will put all this as C star, 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 and star. Because the matrices here are this: G star, C star, and H star. Right. So we can consider this matrices, and you can put it as they are controllable of this sort. Right. And in the reverse process also it happens. And what is observability matrix for this? Q naught is C, CG, Cg power n minus 1. Right. So these two happens, and the controllability matrix for this QC star, controllability matrix for this is H star. Controllability matrix for this is H star, or in place of this we have, in place of H you have C star, and in place of C you have H star. So you have to replace those equations here. H star here is C star, right? And you can find out QC star from this equation and get the derivation of this form, right? And hence you can find out if it is controllable, it is observable. If it is observable, it is controllable, and so on and so forth. Therefore, you can find out the controllability and observability, and say that according to principle of duality, you are going to obtain the relationship between controllability and observability of the dual of the given system, right? Where S2 is the dual of the given system S1.